So that was just up for those people that weren't here yesterday. Okay, so we are doing our very last new material. Tomorrow and Thursday are test review days, but it's also an SAT day. So remember, I gave you your test review early. And I think I'll be here. I don't know. It's around this time I could be done. It might be a little bit longer. So you might be in the media center. You might still be testing depending on who your proctor is. So here's the thing. If you come to the door, it'll either be open, which means I'm here. If it's closed, there'll be a sign on the door that says go to the media center. So you guys will go to the media center if you're not testing. And Ms. Amy Opizzo will take attendance there. So I gave you your test reviews early so that you guys could start working on them. The key is on Canvas, unless that got deleted. I don't even know. Neve, are you in Canvas? Is my stuff in there? Okay. No. So you can be working on that. But Thursday's a really important day in here, guys, because on Thursday I'm going to do the review from front to back. It's 9 multiple choice and 1 FRQ. So and I know I have a lot of students that don't like to look at the key. They like to do the problems themselves and then ask for help if they need it. So use the time before Thursday to do that, because definitely in class I'm going to do the whole review with you guys. And then Friday is a one-day test, okay? So that's where we are. So let's finish up this part of our unit today by reminding ourselves what we learned yesterday, which was the reciprocal identities, the friends. It's really important that you guys know who goes with who. So cosecant goes with sine. Who goes with secant? Cosine. And cotangent would be tan, okay? And this is just like shorthand for saying the inverse. Like cosecant is sine flipped. So sine is cosecant flipped. You could write it either way, okay? Just know that they go together. And we're going to actually do that flipping stuff right now. Yesterday we learned how to graph with those. Today we are going to actually work with the trig functions like sine, cosine, tangent, and then flipping those numbers. Quotient identities, we've already talked about those yesterday. I don't even know if I talked about them, but they were on the bottom of your sheet. But tan, even though tan is 1 over cotan, it's also sine over cosine. And we've talked about that because it's y over x, right? Sine over cosine. And cotan is the reciprocal means so it's just cosine over sine, or x over y, okay? So we need to know these relationships between the different trig functions. It's really important. And so we have basically 3 examples to do. The first one is example 5. And this is basically putting 3 really important skills in one. The first one is how to find a coterminal angle, so we'll talk about that. The second one is knowing the trig, sine, cosine, tangent of the unit circle. And then third is our newest part, which is knowing who the friends are, okay? So first of all, what this is asking for is secant of this angle. And so the first thing you're going to notice is that that angle is not on the unit circle. That's way more than 2 pi. So we're going to use a skill that we've done before, which is find a coterminal angle. So we want to find an angle, the angle that we're familiar with, something between 0 and 2 pi that shares the same spot on the unit circle, which means we need to go full revolutions around the unit circle, which is 2 pi. Remember, you won't have a calculator for a problem like this, so you need a denominator of 3. What's the numerator going to be to make a 2 pi? 6, right? Guys, it's super easy. Listen, you want to make a 2 pi, you double your denominator, okay? So if the denominator is 4, the numerator would be what? 8. Double the denominator. If the denominator is 6, the numerator would be what? 12. That's how you get 2 pi. Super easy. And you sometimes are done by subtracting 1 unit circle, like subtracting 2 pi. You're at 7 pi over 3, but that's still not a unit circle angle. Remember, I need to be less than 2 pi. 6 pi over 3 is 2 pi. I'm more than 2 pi right now. Plus, I don't recognize that. What quadrant is 7 pi over 3? So sometimes you have to subtract more than 1. Sometimes you don't. And that gets us to pi over 3. So what that means is 13 pi over 3 and pi over 3 share the same spot on the unit circle, but more importantly, they have the same ordered pair. You should know that without looking at our unit circle at this point. And so if they have the same ordered pair, they have the same 6 trig functions, sine, cosine, tangent, and the friends. Okay, so now we can figure out what the answer is. Secant is friends with cosine. Cosine is your x. And all you have to do is flip it. Flip 1/2 becomes 2 over 1 or 2. Don't let it confuse you that the formula looks like that. Like, we have a formula. Like, secant of theta is 1 over cosine. So if I did that one column, it's 1 over 1/2. But what happens when you keep, change, flip is you would get keep, change, flip, which would equal 2 anyway. So you don't have to actually do that 1 divided by it. All you have to do is flip it to find the friend. Okay? So, sorry, go ahead. Where? Yeah, if you flip 1/2, right? If I flip 1/2, I get 2 over 1, but we would write that as 2. Well, I'm going to do some more that have radicals in it, okay? So we're at 17 pi over 4, and we need to subtract 2 pi. What's my numerator? Fast. 8. I didn't mean to put them equals. Sorry. So I'm going to subtract 8 pi over 4. That's 2 pi. So I'm going around the unit circle and landing at the same spot, but that still is not on the unit circle, right? So maybe go again. Not maybe. Do go again. And that gets us to pi over 4. All right, I know everything about pi over 4. So now I know everything about 17 pi over 4. They're hanging out the same spot. I know the ordered pair is square root of 2 over 2, square root of 2 over 2. Quadrant 1, everybody's positive. Cosecant is friends with who? Sine. Sine is our y value. All I have to do is flip it. And at this level, we've talked about it before, you can leave your radical in the denominator. That is perfectly acceptable. But I will tell you, you have to know how to clean it up. Like, if you're just happily doing your homework and your teacher says you can leave the radical in the denominator, go right ahead. But I'll tell you, a lot of times in a multiple choice question, they'll have the radical rationalized out of the denominator, which I'll go over real quick again. And I even left some of my answer keys in my homework. I left some of them like this, some of them are rationalized. I want you to be comfortable going back and forth. So remember, if I wanted to get the radical out of here, we've done this a million times, so I'll go over it real quick. Multiply by the denominator. What you do to the denominator, you have to do the numerator. And then you simplify that. That's 2 on the outside, square root of 2 on the inside. Square root of 2 times the square root of 2 is the square root of 4, and the square root of 4, of course, is 2. Those cancel, and you get the square root of 2. So what that means, guys, is this and this, they're the same thing. They are equivalent. They are equal to each other. Either one of those could be your answer. Okay? All right? Let's do 9 pi over 2. That's clearly way off the unit circle. So we're going to subtract 2 pi. What's my numerator going to be? 4 pi. Right? That's how you make 2. It's always 2 pi. And you're going a whole revolution. One full revolution is 2 pi. Is that on the unit circle, 5 pi over 2? Nope. Got to keep going to get on the unit circle. Oh, I know that guy. That's one of my quadrantals, specifically the one at the top, right? His ordered pair is 0, 1. Cotan is the the reciprocal of tan. So tan is undefined at the top, right? 1 over 0. So do it the other way. So instead of 1 over 0, do 0 over 1. It's just the opposite, right? X over y versus y over x. It's just the flip. So 0 over 1 is what? 0. So tan is pi over 2. Tan is undefined. Cotan would be 0. And last one of these, we have negative 17 pi over 6. So I'm not going to subtract, right? I'm going to add. If I subtract 2 pi, I'm going deeper and deeper into the negatives. I'm trying to get to the positives. So I would add 2 pi. What's my numerator? 12 pi. Which gets me negative 5 pi over 6. I'm still in the negatives. There's no negative angles on the unit circle. So we'll go until we need to. And that would give me 7 pi over 6. Now notice, guys, it doesn't have to be a quadrant 1. So this is a mistake, like a common misunderstanding. that when I say coterminal, it doesn't mean it has to fall in quadrant 1. It can be in 1, 2, 3, or 4. It doesn't matter. Any of the 4 quadrants, any of those angles on the unit circle are on the unit circle. So this happens to be in quadrant what? 3. All right, good, Christian. And we should know our denominator of 6 always starts with that. Like, you guys know, I don't need you to write this. This is not work you have to show. Hopefully you don't need to look at your unit circle anymore. But if this is quadrant 3, these are both negative, right? And secant is friends with cosine. Cosine is this guy. Negative. So if you flip something that's negative, is it still going to be negative when you flip it? Yeah. If you flip something that's positive, is it going to stay positive? Yeah. So when you flip it, it doesn't change the sign. It just moves the numerator and the denominator switch places, okay? So as long as you have a negative in your answer, it doesn't matter where you put it, okay? So I usually just put it on top or in the middle. And I have a lot of students like, oh, you can't put a negative in the denominator. We're not that picky about it at this stage of the game. As long as there's a negative somewhere in your fraction, it doesn't matter where you put it. And you can leave it like that, or you can rationalize it. Again, I'll do it real quick. So you could either have this answer or this answer. They mean the same thing. They mean the same thing. Okay? All right, so that's one of 3 types of problems. Let's go to the second type, and this is major review. Okay, this next example. Example 6 on the next page. Find the exact values of each of the 6 trigonometric functions of an angle theta if negative 2/5 is a point on its terminal side. This is going back to drawing triangles in different quadrants. Okay, there's a lot of different ways they can give these to us. You're going to see all of them in your homework, so I'll go over those in a second. But when I see this and it says find all 6, that means sine, cosine, tangent. We've done this exact same problem, but just finding those 3, SOHCAHTOA. Now we're just going to also find their friends. And then we're going to figure out what quadrant this angle would be in and draw the triangle and do all that. So let's just set up our answers. If I need all 6 trig functions, guys, you can put these in any order that you want. Doesn't matter. I'm pretty much do things the same way every time. I like to do sine, cosine, tangent, and then pair it up with its reciprocal friend, right? So sine, I would put cosecant across from it. But the order can always change. There's no rule about what order you put these guys in, okay? You just have to have all 6 answers. What quadrant would this angle be in? Anybody figure it out? 2. Follow the point. Don't forget your Algebra 1 stuff, guys. How do you graph negative 2, 5? You go left 2, up 5. So we draw a quadrant 2 angle just like we've always done. Make a right angle with your x-axis, always. Theta is always at the origin. I went left 2, up 5 to get to this point. Okay, so that was quadrant 2. So you just follow your ordered pair. Now, we're going to use SOHCAHTOA to answer for sine, cosine, tangent, and then we'll flip them to get their friends. But in order to find sine and cosine, we need that hypotenuse, right? So you always, I want to say always are going to need to use Pythagorean theorem to find your missing side, right? These are your legs, that's your hypotenuse. Call these x and y, call them a and b, call that guy a radius. I have hypotenuse to c, I don't care. Just know how to easily find your hypotenuse. Square the 5, square the negative 2, square root of 29 is plus or minus the square root of 29, right? And a hypotenuse is always positive. It's always positive. So, and don't forget all these other little, there's so many little things you guys have to remember, and it keeps coming back. Like, you have to know what SOHCAHTOA is. That's how you're going to find these ratios. You have to know which side's the H, the O, the A. If you don't, how do you name this? So negative 2 would be what part of the triangle? It's adjacent. This is, then of course, your opposite. That's your hypotenuse. Don't forget the stuff that we've learned already. Because really the only new part is right here, right? That's the only new part. All of that is stuff we've done. Okay? So let's just start answering the question. Sine is opposite over hypotenuse. 5 over the square root of 29. I'm just going to leave it like that. And his friend, square root of 29 over 5. Right? That's the new part. Cosine, adjacent over hypotenuse. His friend, square root of 29 over 2. Of course, it's still going to be negative. And tan, opposite over adjacent. And then this is called right triangle trig. Right triangle trig. No, it's not. I'm going to do this last example, and then I'll show you in the homework how the other ways are. I mean, I've shown you before. There's nothing new, but I'll review that with you in a minute. Okay? Last example. You're given crazy-looking sine. You're given a crazy-looking cosine. Find the exact values of the 4 remaining trigonometric functions of theta. So they gave us sine and cosine. So we just need the other 4, right? In any order. Cosecant and secant. Tan and cotangent. Okay. So how do I find cosecant? I flip what? Sine. Just flip it. It's already given to you. So it's 13 over 2 square roots of 13, right? Cosine and sine together. How do I find secant? Cosine. Now tan or cotan, I have to find one of those. That's really the only amount of work there is in these problems. So find one of them and then you flip it. So you can pick whichever one you want to find. It doesn't matter. And then you flip it to get the other one. I'm just probably going to find tan. So remember one of your reciprocal identities was sine over cosine is another way of stating tan. So I'm going to do that. I'm going to do sine over cosine. They gave them to me. Okay? So you could skip this first step. I'm just writing it out this time. But don't feel like you have to. Because you should be able to predict that you're dividing with fractions here. There's sine divided by cosine. And you guys know we can't solve it like that. We're going to have to do that keep, change, flip business like we do 5 million times in here, right? This is sine divided by cosine. They were given to us. I just plug them in. So keep, change, flip, my darlings. Keep your numerator, right? Keep, change, division, 2 times, and flip the denominator. And I see people trying to multiply those numerators, multiply those denominators. Remember, you can simplify before you multiply this out. Anything that's in a numerator can cancel with anything in a denominator. It can be diagonal. It doesn't have to be right up and down. So that square root of 13 cancels with that square root of 13. This 13 cancels with this 13. So you're just left with 2 over 3. Isn't that what I did? Wait, I don't know. I'm confused. Mm-hmm. Yes. Oh, I see. So you're saying you called this opposite, you called this adjacent, and you made it, yeah, oh, that's great. Totally fine. This is not work I would need to see. Do you know what I mean? So if you have another way of finding it, totally fine. Yeah, I never even thought about it, but yeah, that's fine too. Same thing. Yep. And so what's cotan? Over 2, right? Tan and cotan are splits of each other. All right. I never even thought about that, but yeah, whatever. I would still keep teaching it with this because I want you guys to know that reciprocal identity, which is tan over cosine, sine over cosine, because all of these identities next week, you have to know those too. So you really need to know tan is sine over cosine, but that's totally fine. Doing it that way too. All right, I'm going to have you write the assignment down, and then I'm going to explain some of the problems to you to help you get started. I don't see anything restoring to my desktop here. It's making me. It's not his fault. This one I can only blame on myself. This one is me. It still says my folder is empty. I'm going to have a literal heart attack if this is not good. It says my OneDrive is up to date. How can it be up to date? No. Oh my God. I'm just sick. This is not the right thing.
Lie to her? Everything is still here, I promise. Don't yell at me wrong. It's Taylor's fault.
Or maybe call Microsoft. No, call them. They'll help you. Don't even be able to track down what your computer uses.
Everything will be there. I swear. If it's wrong, blame my parents.
It's not his fault.
It is. Tell me to pick you up and leave it.
Okay, what I want to show you guys is this page of your homework. You might want to turn to it because I'm going to help you just, unless you guys have no problems with this stuff, all students take calculus and stuff, you can ignore me. But like 17, it tells you in black and white, you're in quadrant 2, right? It tells you that. So you draw your quadrant 2. This is using your all students take calculus trick. So they're giving you information about tan and cosine, and you can narrow down which quadrant you're in by what's given. They're giving us tan is 4 over 3. What they're telling you right here is that tan is positive. That's what they're telling you. They're giving you sign information, S-I-G-N. Okay? What is this code for? Cosine is what? Negative, right? If you're less than 0, you're a negative. And remember, this is all about who's positive. So in the quadrant that we are going to do this problem in, tan is going to be positive. So I can get rid of wherever tan is negative, right? Because it doesn't meet this criteria. So tan is negative in which 2 quadrants? No, say numbers. Give me numbers. 2 and 4, right? So we know right now tan is positive in 1 or 3. So we're good there. One more little piece of information will narrow it down. Which one of these is cosine negative in? Because that will be our final answer of where we are, right? So this is a quadrant 3 angle. Because cosine is negative and tan is positive in that quadrant. There's another one. Secant. Wait a second. All students take calculus. That's only for sine, cosine, tangent. But remember, we talked about it. If secant is positive, who do we also know is positive? Cosine. Cosine and secant are flips of each other, so they're the same sign. So cosine is positive, tan is negative. So let's get rid of what won't work. Cosine being positive, that means what won't work is where cosine is negative. So it can't be those two, right? Because cosine is positive in 1 and 4. And then between these two, which one am I going to keep? Because tan is negative 4. So that's a quadrant 4 angle. That's how we use all students take calculus. And in fact, the first 4 of your homework problems, these 4 are just which quadrant. So it's more practice of what we're doing right here. And this last one, Nevaeh, I remember going over this one with you. Do you remember how to tell which quadrant this is by this notation? Do you remember? So theta is between pi and 3 pi over 2. What quadrant is that? Yeah, 3. That's quadrant 3, right? Unit circle. Pi over to the left, 3 pi over 2 is at the bottom. That's theta is in quadrant 3. Okay? mean, are any of you like really good at like they know a lot about OneDrive? Because I just want you to look at something if you are like you know about OneDrive. Oh my gosh, my hero. Okay. Oh my gosh, you don't understand. I'm so stressed. So when I go to my OneDrive, right? I don't know what all this is saying. All this stuff has been happening. But everything I want is still in my recycle bin. I want all this stuff. But and look, when I did this before and I hit restore, and then it didn't restore it. I'm so. Here, hit that stop button. The next one.